Okay, is it coming through? You can see the presentation okay? All right. All right, well, thank you very much for the invitation. So what I'll do in the next, about 40 minutes? Is that okay? Is I'll just try to give an overview of what we've done in the Pages Creus working group with attention to some of the initiatives we've tried, some of the new methods we've tried to develop, some of the problems we've encountered, all in the hopes that this might be helpful to your working group, as well as to thinking about methodological innovation and some future collaboration. First of all, I should start by thanking Pages, of course, for support of the group over the years. We're in our 7th year now, so I'll talk about, so we're getting towards the end, and we're trying to think ahead to how we're going to wrap it up and maybe what the next steps might be. Just a moment. Okay, there we are. All right, so just to give a quick overview of where I'm going, I'll talk briefly about the subject of our working group, climate history, and particularly this idea of archives of nature and archives of societies, our two sources of information. Then I'll talk a bit about the activities of the Creus working group, some of the initiatives we've tried out. I'll go through each of those fairly briefly in the interest of time, also because I'm not sure what your interests are, but I'd be happy to try to answer questions at the end to provide more details. I could also try to provide you links to the different studies that we talk about here. And then I'll finish off by talking about possible next steps. First of all, just what is this subject of climate history? Basically, climate history is the study of climate on a human scale. It's a study of how we can reconstruct climate and weather at a scale that is of relevance to understanding human history, particularly over roughly the past 6 centuries, where we have the most information. We can, of course, do climate history on longer timescales and in more distant time periods, but we tend to focus on these last 6 centuries or so, mainly because that's where we have the most information. It's largely that spotlight effect. And we're interested in multiple aspects of this, of course, in just the reconstruction of climate and weather at a fine resolution, but also in understanding impacts and adaptations, how it affected human life individually and societies, both over longer and shorter scales, and how societies dealt with it. Adaptation and resilience becoming increasingly important topics over the last decade or so, as I'll get to. Beyond that, we're also interested in how people perceived climate and how they got to know more about climate and weather over time. In part, this is because it's a key step in using human records in climate reconstruction, but it's also a subject of interest in and of itself. So arguably, the history of climate science and meteorology have a close overlap with a lot of climate history. Arguably, climate history is as old as history in some respects. There are theories about how different climates influence different societies, going back to the earliest works of history in the Western tradition, mentioned in Herodotus, for instance, discussed in writers of the Enlightenment. But oftentimes, these early approaches to climate and history would fall into what we'd now think of as climate determinism. They focused on how climatic conditions shape societies or even races in some deterministic way. And that unfortunately lent a lot of climate history a bad name by the early 20th century, particularly when it was associated with the work of environmental determinists and racists such as Ellsworth Huntington. So as climate history began to emerge as a more professional discipline in the mid-20th century, it was often very cautious. You see 2 broad approaches that were taken. There were historians like Laurent Laderie, whose book you see up there, who were interested in bringing in natural factors, including climate, who were starting to build on some early resources for that work, such as systematic series of grape harvest dates, which indicated summer temperatures. Then, on the other hand, you had meteorologists and climatologists like Hubert Lamb, his book is pictured on the bottom right there, who were interested in history, interested in trying to look at how the climate and the weather that they were studying might have had some historical role. and how the modern techniques of meteorology might be taken backwards into historical reconstruction. However, the field has grown very rapidly only in about the last generation or so. And this, of course, has a lot to do with the acceleration of anthropogenic global warming. The explosion in research in high-resolution paleoclimatology has lent a lot of support to work in climate history. And of course, the increasing attention paid to the impacts of climate change in the present raise questions about how societies dealt with climate change in the past as well. So I'll be talking mostly about this more recent work, although it often builds on older ideas as well. All right. So the two main types of sources in this field come from what we call the archives of nature and archives of societies. This terminology, I believe, was developed by the Swiss historian and climate historian Christian Pfister. And it's what we used in a textbook recently, which I'll get to in a moment. Obviously, these ideas, I think, will be familiar to everybody in this group as well. Basically, we are looking for where either people or nature has laid down useful collections of proxies for past climate and weather, extreme events, hazards, and impacts on societies. The examples from nature, of course, I think will be familiar to people in this audience. Annually laminated layers in lake bottoms, tree rings, ice cores, and so forth. But what climate history is often interested in, or particularly the branch focused on Reconstruction, what we often call historical climatology, is in looking at the archives of societies. This is kind of a strange turn of phrase here, because of course we talk about archives of nature. This is kind of a metaphor for human archives. And it seems like now we've borrowed that metaphor back into discussing man-made sources. But in some ways, that's the idea. It's to look at the compatibility of these and to think about how, in some ways, the layering of human records in personal and official archives is a bit like the layering of information in these natural records like lake bottom sediments or tree rings. It's to look at some of the comparability between the two, the homologies between the two. So I posted a couple examples of what these archives of societies might look like. At the top, you have an example of a high water mark along a historical building in a European city center. This is basically recording major river floods over the centuries, so that some of the early numbers there go back several hundred years. And this is a example of how, in the built environment, you can have these archives of past extreme events, and how these might also serve as a living memory of extreme weather. So it's also an example of how people embed these stories into their culture, into their memory, and how they relate to them. Another example that I've listed at the bottom is an example of an almanac, which has been annotated to show the weather. So almanacs were quite widespread, starting in the late 1500s. Some go back even earlier than that. Of course, almanacs were making big projections about what the weather might be based on then prevalent ideas of astrometeorology. So they would give the different signs of the horoscope, phases of the moon, and so forth, and then imagine what the weather might be. But fortunately for later researchers, some people started to write down in these almanacs what the weather actually was, and that provides a useful record of climate and weather over time. And gradually, people in this field have developed methods for better using that for quantitative reconstruction. So for instance, one of the best proxies for precipitation levels month by month is often just the number of rainy days that people write down in these annotated almanacs. So basically, we can define paleoclimatology then as research on past weather and climate from archives of nature, and historical climatology as the study of past weather and climate from these archives of societies. So basically two specialties, both of which can go into better understanding climate history. Right. So in thinking about how these both fit into this discipline, the discipline has to be really attentive to both the similarities and the differences between these two types of archives, right? And it's also largely a question of how we get people who are specialists in these two kinds of archives to work together. Very often, they're just used in ways that are complementary. They're simply put side by side because they can each contain complementary types of information. We rely to some extent on the continuity, the homogeneity, the relative objectivity of reconstructions grounded in archives of nature, but also the added resolution, the detail, the human interest and perspective of information in these archives of societies. So sometimes it's good just to put the two side by side. The natural archives seem to give some objective backing to the human information. The human information gives that human interest, that detail, the specificity that's often lacking in our reconstructions from natural archives. One of the big challenges that we've been trying to work on in CREAS is just better ways of integrating these two together, not just putting them side by side and asking, do they complement, do they, do they match up and support each other? But what really is our best understanding of aspects of climate, like say monthly or seasonal precipitation or temperature, combining all the information we can get from both of these. And I'll talk a bit about what we've tried to do there. Okay. Now, the CREAS working group really came out of efforts in the 2010s, first of all, to try to compile, to present, to formalize our different methods in historical climatology. Excuse me, I'm trying to change my view here just a second so I can better see my slides. So just a minute here. So somehow the window has gotten stuck in a way that is blocking part of my slides. So you'll see me looking up at a different screen in just a moment. So part of this came from an effort to formalize different methods in historical climatology as the field was kind of maturing in the 2010s and as it was gathering more interest. This also reflected, of course, the growth in stories and histories of climate and society. Work like Jeffrey Parker's trying to sort of rewrite the history of the 17th century as part of a global climate disaster. And also work like mine. I got started in this field by looking at the impacts of drought in the Ottoman Empire in the 16th century, and then trying to write a broader history of how perceptions and challenges related to facing a novel climate in the New World had a major impact on the early colonization in European colonization of North America in the 16th and 17th centuries. So I got involved then in this project, originally led by Christian Pfister and Franz Malshagen, to create a textbook in the field, the Palgrave Handbook of Climate History. Through a series of various accidents, I ended up taking a kind of leading role in this. And it was a great experience for me to try to get people in these different specialties to work together, to each contribute their perspective on climate reconstruction and societal impacts and adaptations, as well as the history of meteorology and climate science. But having done that, it made me realize that having sort of formalized, having stated some of these methods, we could probably go further in integrating them and in improving on them. And so talking with colleagues about what to do, we settled on a working group within Pages, which became CREAS. So CREAS has gone through two phases now. In the first phase, we were focused on reconstruction. This started with a special issue on trying to create comparisons of international methods. We tried to do some work in public outreach, including an online exhibition, if you will, which we called Weathered History, looking at different artifacts illustrating different aspects of climate history. And then we put out a Pages magazine as well, which some of you probably came across. Then we tried to develop a Bayesian approach in historical climatology, a novel approach, which I'll talk about in a minute. And a lot of what we ended up doing, not by design, but it just worked out this way, was collaboration with the Volcanic Impacts on Climate and Society Working Group, the VIX working group within PAGES as well. Then in phase two, which we started after 4 years because we got an extra year on account of the pandemic, we've turned to the question of climate impacts. This involved, again, further collaboration with VIX, but we also turned to writing new sort of method and review articles, trying to think about these problems of how we understand climate's role in human history. And then we put together a couple workshops focusing first on climate and conflict and then climate and migration, both of which involved trying to work with social scientists who are studying these issues in a contemporary context. And now, most recently, some of us in CREAS, including myself, have been involved in a project on the Nordic Little Ice Age. This happened in part, well, mostly thanks to the leadership of Dominic College at the University of Oslo, who put together this project, but also because I ended up moving from the US to my current role at the University of Helsinki. And one of our project members from the beginning was Heli Huhtama, who ended up getting a assistant professorship in Bern, but she is from Finland originally. Sorry about that. Can everybody see my slides okay? Sorry, can someone just confirm that you're seeing this?
Yes,
okay,
it's
great.
okay.
All right, sorry, the Zoom icon disappeared for me, so I was worried something went wrong. All right, so I'll start with our first step here, which was really to try to build more international collaboration in this field. Because this field of climate history, of course, crosses historical studies with the natural sciences, it can often suffer from that problem. I think that a lot of the historical sciences, and especially humanistic disciplines, can have, that they're often very regional or country specific. And this is also the case with climate history for different reasons. Climate historians working in different parts of the world will be working with different types of sources. These can mean different institutional sources. They're used to working in different national and regional archives, where we still get most of our information, but also different types of personal sources. So a lot of our information depends on what individuals chose to write down, as in the example of those annotated almanacs in the European context. In other parts of the world, it's often very different types of personal sources. These can be missionary records, which are common in Africa and the Americas. This could mean even things like poetry in the Chinese context. So there's a wide variety of different sources, and people become very specialized in them, as well as the kinds of information they include. Very often, the most accurate and homogeneous and consistent work we can do from historical climatology depends on records of phenology. So I've pictured a couple examples of that on the slide on the right. At the top, you see a particular lake in Japan that forms a characteristic crack when it freezes each winter. Shrines have been built on either side of that lake where the crack usually forms. So it's considered sort of a special event, as though the spirit of the shrine on one side was speaking to that on the other. And so the date of the event has been recorded for hundreds of years, and it's a pretty good proxy for winter temperature. On the bottom, you see the first cherry blossoms in Japan each year. Their date has also been recorded for close to a millennium now, providing another good proxy for spring temperature. So these things are often nationally or locally specific, as are, of course, the first instrumental records that are kept in different places, which are key for calibrating these kinds of phenological records and descriptions to modern instrumental measurements. So these two require some local knowledge. Also, there's a question of local context. Things are written in different languages, and even if you could translate them, you still need somebody who has a sense of what they mean, who can really interpret them, can understand what is really about the weather and what might be a coded message about something else in society, which is often the case. Cultural context can matter too. For instance, even in official sources, there are, for instance, it's a characteristic of describing the mm, the weather as sort of part of the macrocosm that be reflected by the microcosm of political disorder in, for instance, traditional Chinese historiography. And then there are just simply practical challenges in working across wide areas. Just access to archives, the fact that a lot of the information isn't yet in standard and complete databases and so forth. So what's happened over time is that there have often been very different national and regional schools of historical climatology, of this effort to reconstruct climate from the archives of societies. So we were concerned then in trying to find ways to integrate these different international methods just by trying to create more international contacts and collaboration, particularly between scholars working from a tradition developed originally in Switzerland and in Czechia and other parts of Europe, with researchers mainly in East Asia. Who have developed completely different methods. So the methods that have been developed in China were particularly opaque to us. And so it's just taken time to sort of break down those barriers, to keep talking with people, to try to bring people together, international collaborations. Also to encourage people to explain their methods in ways that are useful for an international audience. It's not just a question of publishing in English or publishing in international journals, which sometimes takes a while, but also in getting people to explain things in a way that would be more clear, reproducible, that would help us understand how results from one part of the world do or do not line up with those in another part of the world. There have been ongoing work too to try to recover data and share early instrumental weather records so that these can be used to calibrate these findings. And there's been some work done as well in explaining and comparing cultural contexts. So my collaborator on this CREAS project, Ching Pei, has written actually a book about this, trying to explain and compare these contexts and the meanings of historical climatology finds in early modern Europe and China. All right, but probably the biggest challenge is in just trying to make compatible what is one of the most common methods or type of method in historical climatology. That's what we refer to broadly as index methods. This covers a variety of ways of trying to convert descriptive information in the archives of societies to some kind of semi-quantitative information, usually by converting it into ordinal indices. So I've pictured here the sort of standard method in a lot of Europe as worked out by Christian Pfister and Rudolf Brasel. And I think this diagram is by Piotr Dubrovolny, illustrating how this works, that you get this information, and usually working backwards, actually, from the most recent, most complete information. You try to figure out at what resolution, both temporally and spatially, you can reliably come up with an index value for certain target variables, usually temperature and precipitation. This index might be from a 3-point or 5-point or sometimes 7-point scale. And then having created these long index series of the target variable, you then work to calibrate them to early instrumental records and then verify that the calibration is consistent and accurate. There are different ways of doing this. And then you use the early index values as a proxy for the target variable that you're looking at in the pre-instrumental period, as illustrated in the final reconstruction at the bottom. Now, this is one version of this index method, but many different versions have been used in different parts of the world and for different purposes. So one of the challenges was just to try to get a grip on what all of those were and to try to test them for their compatibility, and then also to start to look at how reliable this index method is. So some of the first work done on this by George Adams and David Nash, tried to test to see, well, how consistently do people convert this information into indices? Basically, how well does it work in practice? And the answer is, on the whole, pretty well. We haven't gotten to a point where we can say, we have sort of a global index method anymore, or at all. But we can say that the different index methods used do seem to be reasonably reliable and compatible. And some of that information now is being taken into larger databases that combine paleoclimate and historical climate information for reconstructions, also for reanalyses. So some of the work by Angela Bergdorf has been really useful in this regard. However, in looking through these different processes, at least to me and some of my collaborators, it seemed that there were two major problems. One is just that these different historical climatology methods weren't really integrating information from archives of nature, from natural proxies like tree rings, with the written information. Sometimes it was useful not to do that, to keep the two separate, because one might more or less test the other. However, as we in this field of climate history become more aware of research in other fields, there's a danger of circularity when we start doing our reconstructions based on written records, because we often already know, for instance, whether there was a big volcanic eruption, or that there was already this study of tree ring maximum density indicating that this was a very cold year, and so forth. It's hard to unlearn that information. So I think we were often kind of falling into a circularity with our reconstructions. And then when they didn't agree, there wasn't really much we could do about it. If the tree rings were saying, I don't know, 1540 was a dry year, but not really dry, but the historical climatology was saying, actually, this was the hottest, driest summer in Europe until the 21st century. What could you do about it, right? We really needed to search for some kind of integrated approach. In addition, while we're finding the index methods were reasonably reliable, studying them more closely to me revealed certain limitations. Index methods worked best where you had really abundant, consistent information. But for most of human history, we don't have that. We have scattered, inconsistent, in some cases, not very reliable information, but information nevertheless from these archives of societies. Moreover, even when we had really good, abundant, consistent information, our reconstructions were losing low-frequency variability. They were doing a good job of showing basically interdecadal variability in things like temperature, precipitation, but not really what we wanted to know about longer-term changes. And they tended to have a sort of conservative bias in results. They tended to underestimate variability altogether because of the nature of the indexing. Basically, historical climatologists were reluctant to assign high or low index values when they didn't have really strong information. So to me, the way in which we could get information from these sources wasn't really being fully captured. It wasn't always telling us what we really could know based on the kinds of written descriptions we have. And this kind of took me down a rabbit hole in thinking about historical epistemology, which I won't get into here because this was sort of became a sort of pandemic project of mine, where I know a lot of us were, sort of going off into strange directions with our methodology. But in this case, it did lead to a sustained attempt to develop a Bayesian approach, for which we eventually got some funding from the Swiss National Science Foundation, and I took a sabbatical in 2022 in order to try to work this out. So basically, there had been previous Bayesian methods that tried to use sort of fuzzy information from historical sources. They were Bayesian insofar as they were just interested in saying, okay, well, I have either two types of information, I want to put them together, or one type of information is fuzzy, so I want the sort of probabilistic reconstruction that I could get from a Bayesian method. But what I wanted to do was to say, okay, we have all of this work already in indices. Can we build on that to make some more consistent Bayesian approach, and one that really captures all of the information that we can get from modeling, from our paleoclimatology, particularly high resolution paleoclimatology and known climate forcings, as well as these written records, which may be inconsistent, may be sparse, may be sort of impressionistic, but nevertheless can give us certain types of information. And just to take a quick example, we have many cases in which sources might only tell us when they think that, say, a winter was extremely cold, but not when a winter was just average. And so the kind of information you can get from this is peculiar, right? Not every time that they say this was the coldest winter ever, was it really the coldest winter ever? First of all, people only tend to remember about the last 40 to 60 years of weather. But second, people tend to exaggerate winter cold. So when somebody says that, I can't say for sure it was the coldest winter ever, but I can say that it is improbable for someone to write that if the weather was warm, and more probable for them to write it if the weather was at least very cold. Conversely, people don't usually bother to write the weather was average this winter. But if they do, you can be pretty sure that it was not very hot or very cold. Otherwise, they'd have no incentive to lie about that. On the other hand, there's always some chance that the information is wrong because sometimes there are things like dating errors. In any case, we can express that in a Bayesian format, at least I believed, in a method like this, where we would take a ensemble of climate simulations and basically use a forward model to show what kind of prior probability distribution that would produce, converting that into these index values. And here I've referred to the Pfister indices, but that just means an index value from -3 to +3 for our given target variable, in this case, seasonal temperature. And simply using Bayes' theorem, we can multiply that prior probability by the likelihood of getting an observation assuming a different state of the climate to produce a posterior probability distribution. So we tried this out for data that we had for the Burgundian Low Countries in the 15th century, 15th century being a period which we start to get information, but it's not 100% consistent and reliable. So it was a good target period for this. And we were able to produce what I thought were really interesting reconstructions that really demonstrated the full range of our knowledge and our uncertainties. Now, having done this, I'll say that it ended up having both advantages and drawbacks. The big advantages was obviously that it was able to integrate more than one type of source material, and definitely was a better use of the information in our historical sources. It wasn't just simply taking them to mean, that if somebody says it was hot, it was hot. If somebody says it was cold, it was cold. Or if the information was bad, we throw it out. No, this allowed us to really express how this written information should update our probabilities. So I think it really gets the essence of the Bayesian approach. It actually, and the results therefore actually reflected both our knowledge and our uncertainties. Now, the drawbacks here was that it turned out to be much harder to use. And the results were often harder for people to interpret because what you're getting is a posterior probability distribution, not one value. And that posterior probability distribution was, of course, non-Gaussian. It didn't have to follow a nice, neat bell curve. And that made it really difficult to use with other kinds of methods that people have developed. Plus, the result was hard to explain to historians, and the methodology was often hard to explain to people trained in historical sciences who just weren't used to a Bayesian approach. Now, the reason that this approach hasn't caught on farther, though, doesn't have much to do with these theoretical advantages and drawbacks. It's just simply that two of the main collaborators in this project, Chantal Kamenisch, who was the lead author, and then our modeler, both ended up going into non-academic careers later on. And then my colleague Ching Pei picked up on this, but he got funding, he sort of started moving forward with this, and then he had a postdoc who was ill, and basically it's all been a series of practical setbacks, but hopefully we will continue to move on with it. In the meantime, we moved on to phase 2 of CREAS, where we started to look at impacts. Now, the first big part of this here, and I realize I'm taking more time than I expected, so I'll be fairly brief, was just trying to settle sort of larger theoretical issues in the field. The field from the 2010s into the 2020s started to shift more into questions of adaptation and resilience. So some of this came from criticisms of previous climate history studies that had focused on basically long-term large N studies of climate change and impacts, like it got colder, there was more conflict. Part of this had to do with criticisms of data sets. Part of this had to do with finding that some of these results from these studies were the result of artifacts, mainly autocorrelation. But in the meantime, there were other debates in other fields from archaeologists, from historians, particularly pertaining to impacts of the so-called late antique Little Ice Age in the 6th century, which it really involved scholars trying to shift the discussion onto the stories of hope and resilience, away from these stories of impacts and basically doom and gloom. Now, Ching and I discussed this in an article, a brief article. Basically, we argued that a lot of these divergences had to do with different standards of causation and attribution. But then working as a wider team, our CREAS group carried out a bigger review article, which came out at the end of 2022, early 2023, where we tried to look basically at how the field was changing the nature of its questions. And I won't get into these specifics here, but we tried to make some claims in that article about how we might basically improve some methods here. It was also around this time that we realized that volcanic eruptions were making some of our best case studies. So I'll note this here, just because I imagine this might be of some interest to people in traces as well. Basically, that because of recent technical improvements, the study of volcanic impacts on climate and society had changed a lot. There has, of course, been improved dating of tephra in ice cores, so you can get down to the exact year that a lot of eruptions took place. Tephra analysis has made big advances, also mass spectrometry, so you could figure out, for instance, whether sulfate deposits reflected volcanic eruptions that had reached the stratosphere. And at the meantime, changes in dendroclimatology made a difference too. So studies that were using maximum late wood density or blue intensity were improving the sharpness of reconstructions of volcanic-induced cooling. So that really helped us understand that volcanic forcing played a bigger role than previously understood in high-frequency temperature variability throughout the Holocene, as well as advancing studies that showed that volcanic eruptions, particularly a series of large eruptions, might also have longer-term climate effects. So we ended up working more than we had originally expected with people interested in volcanoes. I list a couple examples of studies where we tried to integrate the historical climatology with paleoclimatology to understand volcanic forcing and impacts. And then Heli's project has her big ERC project, which she's been working on now in Bern, has focused specifically on case studies of volcanic eruptions and their societal impacts. Now, for most of the work, though, on trying to understand the impact side of this project, we tried to focus on comparing past and present impacts. So just to give some quick background here, obviously the fear in addressing climate impacts on society, particularly big impacts like conflict and migration, has always been that we're going to end up in some sort of climate determinism. We're going to simplify the causation here. So my idea was that we really need to work with advances in the social science on climate conflict and migration, because we've now had, more than 2 decades of obviously of clear accelerating man-made global warming, which has provided many case studies, lots and lots of data to understand how climate does and does not influence conflict and migration. So we arranged a couple of workshops in Oslo in 2023, then in Brno in 2024, in which we tried to work with these scholars in the contemporary social sciences. Now, to summarize a complicated field, and again with a mind to how this might help those of you in this working group, I basically came to the conclusion that a lot of us working in the historical sciences should be more cautious. We should think about what we can learn from the present before we start trying to teach lessons from the past. And I think this is maybe especially a problem for historians here. Present events offer just so much more information and can be used as ways of developing fairly sophisticated models of understanding impacts. And these got me to realize that a lot of the work we'd done historically was off on the wrong track. We were asking whether climate change influenced conflict or whether climate change caused migration. When we really should have been asking more detailed questions about when, who, where, and how, right? Some of the big findings, especially from contemporary work on climate and migration, is that global warming may or may not actually have any big impact on the total net numbers of long-distance migrants, but it is having many, many complex and significant impacts on when people are moving, what groups of people are moving as opposed to others, where they're moving, how far, and especially under what conditions, whether these are adaptive or maladaptive conditions. So we need to ask the same kind of questions about history and then think differently about what the historical perspective might contribute. I think we can say more if we move away from looking at these short-term impacts and think about long-term causes and effects and what history might have to say about continuities and discontinuities, and also how historical perspectives can in some cases improve our narratives about climate and human impacts, as well as the contribution of historians and public outreach. I'll skip over this, but these were just some examples from sort of the contemporary social science research, for instance, of climate and conflict, and how we tried to use them to sort of improve on some of our historical interpretations. This coming from really great information from new indices, databases of work on extreme weather and climate in historical China, which can also be shown graphically here. All right. So now just to wrap up, because I realize I'm going on a bit too long on time, we just have a couple more events within this Pages Creus group. We'll have a session at the upcoming Pages OSM, and then we'll have our final workshop, which will be held in conjunction with the European Society for Environmental History in Uppsala in August 2025, where we'll try to think of some kind of synthesis product, perhaps. We'll also try to use that last workshop to think about what next steps might be. I'm interested really in still kind of trying to simplify and to extend some of the Bayesian methods for reconstruction that I talked about. But there's also discussions about possible new working groups or projects. The historical study of heat waves has been raised, also climate and weather in cities. I think these are all promising. So we'll see what gets the most attention and what we might do, including possible collaborations with your group. That's all. Be happy to take your questions now. And I will stop the sharing.
And I stopped the recording.